Good morning, guys, and welcome to another lesson on completing the square. This one's going to go into a little further detail and show how you can use completing the square to solve some quadratic equations, even if they don't quite look like what we're used to seeing. So written on this page right now, I have x squared plus 4x minus 5 is equal to 0, which is pretty similar to what we worked in our last lesson. I've already put 0 in for the y value there. So it's really like we're solving for x-intercepts on a parabola, if we're thinking about what this would look like graphically. So let's just quickly review what we would do there. For one like this, we would go ahead and start by trying to fill in our parentheses of what's going to be squared. And to do that, we would take x squared and just turn it into x. And we would take our positive 4x and divide it in half, so that 4 becomes 2. So right now we have x plus 2 squared. We aren't quite done yet, because if I were to actually multiply x plus 2 times itself, I would get x squared. I would get 4x if I added those two x's together, which is what I started with. But I would also get positive 4 when I actually had negative 5 to begin with. So this is where we have to keep our equation equivalent as we go through this process. So since I have positive 4 already in x plus 2 squared, but I was supposed to have negative 5, I have to think, okay, how do I go from positive 4 to negative 5? I subtract 9. Another way you could arrive at that negative 9 would be to do this minus 5 minus 4. So you can always do that. You can take this third value in your equation and subtract what you get when you square the numeric term in your new completed square. But right now I have x plus 2 squared minus 9, and that's all equal to 0. So that was the process of completing the square. If I continue this to solve for x, this one works out really nicely. So just rewriting my equation where I've got some room to work. I can now add 9 to each side. So I have x plus 2 squared is equal to 9. And now I'm looking at undoing squaring something, so I take the square root. When I take the square root, x plus 2 is equal to positive 3, but we have to remember it could also be equal to negative 3. And then my last step would be to subtract the 2 from each side, so I would get x is equal to 1, or x is equal to negative 5. And that's solving that equation. That was something you've already done. You can see another example and hear me talk a little bit more detailed about this process if you go back to the video from last week on completing the square. But the purpose of this video today is actually to talk about ones that maybe look a little bit less familiar. So instead of what we just saw, let's look at one like 2x squared plus 9x is equal to 12. So just at first glance, this doesn't really look like it would be one that would be the same as the first one. But let's see what we can do. So we're used to using completing the square to solve when the equation is equal to 0, not a number like 12 here. What that means is that we need to go ahead and make this look a little more familiar. So if we were to subtract 12 from each side, all of a sudden we would have 2x squared plus 9x minus 12, and that would be equal to 0. So that's great news. We're really looking a lot more like we were in the previous problem. Another difference, instead of just x squared, we now have a 2 in front of it. And that makes things a little tricky, because we can't just say, okay, well, that's going to be x in the parentheses still, and then go from there. We actually have to get rid of the 2 before we do anything else. So one thing we could do is we could take and divide the entire equation by 2. And I said entire equation, meaning everything on the left side and on the right. By doing this, we get x squared, and even though 2 doesn't go in nicely to 9, we can still do the math and get 4.5 x, and then minus 6, and then 0 divided by 2 is still 0. So now we've got 4.5 there, but we know how to deal with that. It was just really important to get rid of the 2 in front of the x squared. So now that we've done that, let's go ahead and see if we can use this completing the square process. So we'll start the same way we have been with our parentheses squared, and in there we'll take x squared and turn it into x. Our sign is addition, so we'll keep that. And now 4.5 still is divided in half to give us 2.25. To figure out what's going outside the parentheses, we can do that same check we always have done, where we say, okay, what is x plus 2.25 multiplied by x plus 2.25? We get x squared. We get 2.25x in each box. And then I better check on my calculator what 2.25 squared is. So if I do 2.25 times 2.25, I get 5.0625. 5.0625. And that's the value that we really cared about, because that is what we created inside these parentheses, even though originally it was minus 6. So we have to go from positive 5.0625 to negative 6. This one, let's just jump straight to that trick here. So if I do negative 6 minus 5.0625, well, that's like adding a negative. So that's going to give me minus 11.0625. And we can think about that now. 5.0625, which is positive, minus 11.0625 would take us to negative 6. So that's the value we needed. All right. So we've got our completed square. It's still equal to 0. Now we can solve this equation the same way that we've done the other ones. So if I write it again, x plus 2.25 squared minus 11.0625 is equal to 0. I can start out by adding that to each side, so let's do that. And then we'll see x plus 2.25 squared is equal to 11.0625. If we go to the next page, so same thing. Now we can go ahead and undo by square rooting each side. The square root of 11.0625, let me check real quick. So we take the square root of 11.0625. We get 3.326, and we know it has to be positive or negative. So 3.326, but also negative 3.326. So that sets us up to have two equations where x plus 2.25 is equal to each of those. If we subtract 2.25, in each of these equations. Our first one will end up with x being equal to, let's just see real quick here. So we're going to get 1.076, and then here we're going to get negative 5.576. Just like before, we end up with our 2x values, which have solved the equation. If you look at when we rearranged that equation previously, you'll see that when we set it equal to 0, it's like we found the y-intercepts for the equation 2x squared plus 9x minus 12 is equal to y, or equal to 0. But be careful, because technically those aren't the y-intercepts of 2x squared plus 9x equals y. Those are the values for x that would make that equal to 12 on the other side. So be careful with how you think about that. But this is the method you'll use in that worksheet that's assigned on Google Classroom. As always, be sure to use those office hours between 9 and 11 to ask me questions through email or on the assignment in Classroom, and I'll answer you promptly so we can get you through this assignment. All right, guys.